In this video, we'll look at the pre-calculus algebra topic of absolute value inequalities. This is part 2 of a video where the first part of the video we looked at some linear inequalities. Now we'll look at some absolute value inequalities. Here's a short review that might help you. When you see less than, if you think less than, when we have an absolute value with a less than, we're going to have an intersection. So if we drop those lines from the absolute value and just see this as x is less than 7, that's the x is less than 7, and then we're going to say and at the same time x has to be greater, so flip it from less than to its opposite, so in this case greater, the opposite of 7. Now this is the approach, so by this I mean using this mnemonic that when we see less than we see and. This approach is more of a memorize the rule approach. What's even better at this level, now that you're in pre-calculus, what's even better is if you can just understand what this means. What does it mean when we say that an absolute value is less than 7? By definition, do you remember that absolute value is the distance from 0? It's the distance from 0. So what we're saying for absolute value of x that's less than 7, we want all the x's whose distance from 0 is less than 7. So do you see how easy this could be? I could get this answer pretty easily by thinking through the absolute value is distance from 0. So all the x's whose distance from 0 is less than 7 units would go from -7 to +7. But you could also do this if you need to for a little while until you really feel like you understand it. All the x's that are less than 7 would be this pink. All the x's that are greater than -7 would be blue. Which x's were both pink and blue? Well, that's from -7 to 7, what we got initially here. Let's look at greater. When we see great or, think or. So we're going to see that this is the absolute value of x greater than 7. That's all the x's that are greater than 7. So we just copy this x, drop the absolute value, x greater than 7. Or the opposite direction, so x, all the x's that are less than the opposite of the greater, so less than the opposite of 7. Again, I could do this by graphing all the x's greater than 7, all the x's less than -7, and this or is going to give me from -infinity up to -7, or 7 to infinity. But again, I can't say enough how much better it would be if you can grasp this concept from a conceptual point of understanding that this statement, the absolute value of x greater than 7, means all the x's whose distance from 0 is more than 7. So we're going to start at 7 and negative 7 and go out. So one way or the other, you want to be able to evaluate absolute value inequalities. Best approach would be to really conceptually understand it as a distance from 0. But if to start with, you need to use these mnemonics, great or, we have a statement with an or, less than, we have a statement with a intersection, and, then that would be a okay way to start. Let's look at some examples. When we have the absolute value of 2x minus 6 is less than 8, remember again, we're saying that all these 2x minus 6's are sandwiched between the opposite of 8 and positive 8, because the distance from 0, here's our 0 mark, that distance is 8 units. Let me go ahead and write it out using that mnemonic also. Less than, so we're going to have 2x minus 6 is less than 8, and 2x minus 6 is greater than the opposite of 8. If I put those together, do you see, we'd start with this negative 8, and we'd have negative 8 less than 2x minus 6. Let me show you where I'm getting that. Negative 8, reading it from backwards now, less than 2x minus 6. And then the 2x minus 6, it's already there, less than 8. So we're putting this 2x minus 6 sandwiched between the negative 8 and the 8. From there, you'd want to solve the inequality. So we're going to add 6 to all three pieces. Negative 8 plus 6, negative 2 is less than 2x, is less than 14. Divide everything by a positive 2 to get negative 1 less than x less than 7. So it looks like we get all the x's from negative 1 to positive 7. Trying one more example. We're going to sandwich this in again. We've got the distance is less than or equal to 8. So that's going to look like this. Negative 8. Oh, sorry, I didn't mean to move that. Let me see. Negative 8 and 8. And we've got this expression sandwiched between there. If I simplify that, I'm going to erase some of this other part. You could always pause or rewind to go back to that. But so that we have plenty of room to show this, we've got negative 8 less than or equal to 2x minus 2 plus 4 less than or equal to 8. Do you see how I distributed the 2 to the x and the negative 1? I could simplify this negative 2 plus 4 is positive 2. So negative 8 less than or equal to 2x plus 2 less than or equal to 8. Subtract 2 from all three portions. So we've got negative 10 less than or equal to 2x. The 2 minus 2 cancels each other out. Less than or equal to positive 6. Divide by a positive 2. Negative 10 divided by 2 is negative 5. Less than or equal to x. Less than or equal to 3. So we've got all the x's starting at negative 5, going up to and including the 3. Let's look at one more example. This less than. Remember, for a less than, we're saying that solve the inequality 1 is less than this absolute value. I'm going to start by flipping it around. And to flip it around, we just read it from right to left. So the absolute value is greater, so if I'm reading it backwards, greater than 1. Can you do that? Can you flip? Do you see how to flip these around that way so that I have that absolute value on the left? So what this is equivalent to is the absolute value of 2 minus 3x greater than 1. Greater than 1 on a number line, if I'm understanding this, we're saying that the distance from 0 is greater than 1. So that's starting at 1, starting at negative 1, and going out, all of those x's, so that 2 minus 3x is fitting there. So we have an or. It's going to look like this when I write it out. The 2 minus 3x greater than 1. So I'm just copying the statement but dropping the absolute value. Or, because it's great or, so that's union. And then we've got our 2 minus 3x again, but I'm going to flip it to less than, and then the negative 1. Solve each of those inequalities. So we have negative 3x greater than 1 minus 2. Now be careful here. When I divide by a negative 3, this greater than has to flip to a less than. Whenever you divide by a negative, it flips. So x is less than 1/3, or if I solve this for x, so subtract 2, negative 3x is less than negative 3. Dividing by negative 3, so watch this carefully. When I divide by a negative, the less than flips to greater than. So we've got x greater than positive 1. So this is going to, on a number line, we're less than negative 3 or greater than 1. Let me do it in color that matches. Less than negative, or less than 1/3 is going to go from negative infinity up to 1/3. Or greater than 1 would be 1 to infinity. If you're not confident with getting this interval from these statements, then let me encourage you to jot these on a number line. X less than 1/3, or greater than 1, x less than 1/3 would start at 1/3 and go down. Greater than 1 starts at 1 and goes up. I hope that this video has helped you with these topics, and I hope my cough isn't annoying you too much. I'm so sorry about that. But if you do have questions about these examples, please jot those down and bring them with you to class. I look forward to engaging with you in class with any of the questions you have. And thanks so much for making time to work through these videos and to get the practice in.